Okay, so what is the parameter? Absolutely. I forgot the at Sharon School, but yes, you should have at Sharon School there. The true proportion of students at Sharon School who can identify the smell of a skunk. And my pen decided to turn itself off. All right. Null hypothesis. What is the null hypothesis? P equals 0.90. What is the alternative? P is less than 0.90. Why does that sample result of 84 out of 100 give some evidence for the alternative hypothesis? Because it's less than 90. That's exactly right. So, conditions. What are the three conditions? What are the three conditions that we need to check? Randomness, 10%, and normality, large counts. We do 10% for what reason? To see if it's independent. Double check that it is independent. We get our randomness. It says random sample of 100 students. Do we get our 10%? Yes, we do. As long as there's at least 1,000 students, we get our 10%. And do we get large counts? Yes. Barely. Once again, we have one that comes out to exactly 10. Standardized test statistic, that is the z-score, and the p-value. First thing you need to do if you are asked to calculate a standardized test statistic and a p-value. We know from our large counts that it is approximately normal. When we are working with normal things, what's the first thing you need to do? Draw a picture. Show me your artwork. So we're going to draw a picture there. You need to have the mean of 0.90 in the center. You need to find the standard deviation. Standard deviation is the square root of p times 1 minus p over n. So 0.90 times 0.10 over 100, and then square root. And then our sample proportion, 0.84, is less than 0.90, so it's to the left, and then we shade to the left. There are two different ways you can go about calculating this. You can use normal CDF, or you can find the z-score. That's our standardized test statistic. Z-score comes out to be -2. What does that mean if it has a z-score of -2?
It's exactly 2 standard deviations below the mean.
It is exactly 2 standard deviations below the mean. That's absolutely correct. Whether you use the standardized test statistic and table A, or whether you use your calculator, what does our p-value come out to? 0.0228 or 2275, depending on whether you're using table A or your calculator, but they're very, very, very close. So what conclusion should Sharon make? We have convincing. You're doing great so far.
We have convincing evidence that students in Sharon School, less than 90% of students in Sharon School can identify smells.
Yes. And so do we reject, fail to reject, or accept?
Fail to reject.
The P is low, so reject. Right. And I forgot the at Sharon School part, but I should have had that in there. So because 0.0228 or 2.28% is less than 0.055%, We have convincing evidence that less than 90% of students at Sharon's school can identify the smell of a skunk. Fantastic. All right. So what we did yesterday and what we're going to do today is called, we're going to run a significance test. We've done almost all the parts of a significance test at this point. We're going to run through a complete significance test today. If you go ahead and flip your packet to page 9. We are going to run a test. Can somebody read what is up in the little box on page 9? Anthony.
Many students claim that they can taste different color skittles. Today we will conduct an experiment and perform a significance test to see if students really can taste the rainbow.
All right, so we're going to see if you guys can taste the rainbow. I need everybody to find a partner. Cool. We have an even number of students, so we need 8 groups of 2. 8 groups of 2. Find a partner, or I will start assigning partners. Everybody needs to find a partner.
Not in the slightest.
Yes, you're just here.
No, they're not.
All right. Guys, we got to move through this part quickly because this is going to take a little bit of time. So between the 2 of you, does everybody have a partner? Let's start there. Does everybody have a partner? Who does not have a partner? You don't have a partner. Who else does not have a partner? All right, I'm going to partner you with Elijah then. You need to decide who is going to taste first. So decide which one of you guys is going to be the taster first. Non-tasters need to come up here. Tasters, you stay at your seat. Non-tasters need to come up here. Those of you that are tasters, you are going to have to close your eyes because the idea is, can you guess which color you are tasting? Those of you who are up here in front of me, the non-tasters, you are going to take a little cup of 5 Skittles back. Your partner should not see it, so keep it in your hand, keep it closed, because these are clear containers, because that's what I had. Once your partner has their eyes closed, they will select 1 Skittle. Tasters, you need to show that Skittle to the other person, to your partner, so they can see what color it is. And then you're going to put it in your mouth. You're going to make a guess as to which color Skittle you just ate. And you guys are going to record whether they got it right or wrong. All right? So 5 Skittles, right or wrong. When tasters are done tasting their 5 Skittles and making their best guesses, then you guys are going to switch positions. And those of you that are recording the first time will get to be the tasters the second time around. All right? Does everybody understand the scope of what we're doing? Yes. Fantastic. Okay. You. Only the person tasting the Skittles should touch the Skittles. I did not touch them when I put them in the cups. You're welcome. I do need these little cups back, so please don't destroy them. Sorry. All right. Those of you that are tasting, you have to close your eyes. Don't forget to show the Skittle to your partner. Then taste it and make a guess. Recorders, you want to know whether it's right or wrong.
Star Wars. Oh, okay. Is that right? I can't.
It is green.
Wrong. Next one.
It's red. It's red.
Too late.
Oh.
It's red. I can tell it's red. It's red. No, it was red.
Too late.
But was it red? No.
That's okay. Decimals are okay. Answers, we've got lots of decimals.
It's not yellow.
Orange.
It was orange.
Yeah, so close. Okay. I didn't see the color.
This is not purple.
You have to have a hand.
Is it purple?
Blind.
I just purple. Wrong.
Actually, not that. Wait, did they report their score on their paper?
That's great.
Just jot it down. We're gonna have the whole class total.
Oh, no, that was green.
Nah,
This is your green one.
I
This
feel
is red.
I assume there's probably like one.
Don't tell them whether they got it right or wrong. Don't tell them whether they got it right or wrong.
They are different flavors though, I will say
There we go.
Not so much. Oh, okay. You are welcome to spit them all out.
That's purple. For sure.
Yeah, they look yellow.
Well, I guess we got it both.
Oh, it's your turn. Yellow. You got yellow and purple. And then he said yes, for sure. So it's purple. For sure. We switch now?
Yes. So put the empty one here. Grab a full one.
Close them eyeballs.
Right. Grab a full container. There you go. Stack the empty one there and grab a full one. Don't worry about that right now. Just record the total. Stack the empty one. Grab a full one.
Okay, over your hand. Okay, go ahead.
Thank you.
All right, Brandon, close your eyes. All right.
Wait.
No, purple or purple.
All right.
All right. Sorry about it being paused up until now. All right, so specific formula. We want to find our standardized test statistic. Standardized test statistic. What we mean by that, we take the statistic minus the parameter divided by the standard deviation. So that is a Z. You have to know what it is or how to find it. So if you don't want to write that whole thing out, you still need that big idea. So Z equals P hat minus P over the square root of P times 1 minus P divided by N. We use P, not P hat. So what was our P hat again? 0.36. P is assumed to be 0.2, 0.20 over the square root of 0.20 times 0.80 divided by what? Divided by 80. Go ahead and calculate the z-score for us. Test you again. What is the z-score? 3 point what? You said 5.8. I got 5.6. That second decimal point, like if I get 3.56, you get 3.58. That makes very little difference in the whole thing. All right, let's draw our picture. Get our normal curve in. What should go right in the center? Mean, which is 0.2. What did we calculate the standard deviation to be? 0.044, 0.045, depending on how you rounded it. Again, that last digit, like, I'm going to look at it. It should be close to mine. But if you're 1 digit off from mine, that's not going to cost you any points. Our test statistic was 3.58. What does that tell us? 3.58 standard deviations away from the mean. To the left or to the right? To the right. How far does a normal curve normally usually go? Takes me out 3 standard deviations. So this guy is way over here. There's our 0.36, and we're going to shade it in. We still need the n with the mean 0.20 and the standard deviation 0.045 or 0.044, depending on what you used. And now I want you to calculate the p-value. Calculate the p-value. Keep in mind, table A only shows you the less than. Do we want less than? We shaded to the right. We want greater than. So you would have to do 1 minus whatever you find on table A if you use table A. Does anybody have a p-value for me? Really, really small? Yes or no? What do you guys think?
Yes, it's small.
Yes, it's supposed to be very small. Why should it be so small?
Because we're way above the mean.
We are way, way above the mean. Think about our empirical rule. 68, 95, 99.7. So already we're looking at most 2.5%. But we're more than 3 standard deviations away. What do we get for a p-value? 0.0019. That sounds about right. So what is our conclusion? Mm-hmm.
More than 20% of students.
Close. I think you're getting lost in some of the numbers, but I really like where you're going with this. First thing we need to do, and we haven't done this in these up till now because we've just still been talking about what p-value is, but I guarantee you if you go into anybody in an office and you go, hey, do you know what a p-value is? They're going to go, what? So this 0.00019, we kind of need to explain what that is. What was the assumption that we made at the beginning? What was our null hypothesis? Yes, so assuming HO is true, assuming the HO is true, and then I'm going to state what that means. P is equal to 0.20. There is approximately oh, sorry, my writing went all over the place there. There's approximately a 0.019% chance, or percent probability, of getting a p hat, or sample proportion, of what was our sample proportion? 0.36, right? 0.36 or more extreme. What would the more extreme be? Less than or greater than? Or higher. So 0.36 or more, purely by chance. Kind of, yeah. We start off by interpreting that p-value. And then we make our decision here. So if you want to think of it this way, if somebody says, so can your students really taste the rainbow? I'm going to say, yeah. Yeah, I'm convinced that they can. And they say, why? And I said, well, I got a p-value of 0.00019. You go, what? I said, assuming they can't taste the rainbow, assuming they were just guessing, there's approximately a 0.019% chance of getting the results that I got in the class from my students purely by chance. And so I am going to then conclude that my students really can taste the rainbow because 0.019% is less than 5%. So because 0.019% is less than 5%, what do? Reject, accept, fail to reject, reject. We reject the HO, and we do have convincing evidence that this class can taste the rainbow. So first, we interpret the p-value, and then we make our decision. That's to reject or fail to reject. And our conclusion, which needs to include context. Yes?
Where'd you get the p-value?
Calculator. Okay, so second vars, normal CDF.
Okay.
And then we're going to put in our lower bound, which would be 0.36. Our upper bound would be like 1,000, I don't know, right? Because we went to the right. And then the mean is 0.2, and the standard deviation was 0.045.
Today I was having, because I had, what I do sometimes.
super tiny.
Okay, but then what do we need to find the what do we need to find the z-values then?
So that we can do this. So they're going to ask sometimes for the
Oh.
standardized test statistic. How far away from the mean are you?
Okay.
All right. Oh, sorry. All right, so that right there, everything on page 9, running top to bottom, is how you do a significance test. Homework is due Monday. Homework is due on Monday. You guys are going to run a significance test, top to bottom. So we still do state, plan, do, conclude. In the state step, you need the parameter, the hypotheses, the statistic, and the significance level. 4 things go in state this time. Plan, same thing. Name of the procedure, check your conditions. Do, find your standardized test statistic, find your p-value. And then your conclusion, you need to interpret the p-value, so explain what that means, and then you need to make a decision and a conclusion there. So far, so good? All right. We will continue practicing with this, but homework is due on